So first up, we are going to have a little talk about, let's see, formula-driven materials. So this topic actually came up quite a bit during the morning sessions in the chat, as well as some of the presenters were including this in their presentations. This might not be a topic or a feature that you're aware of. So to get our bearings before we talk to Jacob, I wanted to invite Lenny up to basically give us an understanding of what we mean when we say formula-driven materials.
Hi, yeah, hey Clay, thanks. So basically, right now our materials are static. So meaning the name of it, the thickness, all the attributes is a static value that lives in a database, and it gets synchronized to the workbooks so that our cabinets and stuff can use that information. This works fine for some people, but sometimes in way older versions, like before Microvellum went to a database, people would use a formula. So that way you have the name of the material would be formula driven based on some other inputs. And so the same with the thickness. So, and you could do things like the thickness could be the sum of the core, the liner, the laminate, stuff like that. There's a much more dynamic way of doing it. And so that's basically what we mean by formula driven versus static.
Mm-hmm. And so what would you say some of the primary benefits are when you look at non-formula and formula driven materials?
Well, the benefits are there's less, where do you start? There's less synchronizing. So right now, let's say if everything was static, that almost becomes like an astronomical inventory, right? Especially if you consider all the different laminate options and veneers and cores and finishes. Even it becomes unwieldy to maintain. And so by having a formula one, then what you have, instead of having thousands and thousands, you have like a couple dozen rows of these like smart materials that are just the names and the thicknesses are dynamic based on like a custom wizard that you would input.
Right.
That's the advantage. The disadvantage of that is when you're connecting to other ERP systems, often we need to know what it is. It has to just, it can't be calculating. And so there are some disadvantages that are things that you have to be aware of.
Well, let's take a few minutes and hear from someone that has experience in setting these up and has integrated them throughout the library. And so Jacob, Edmond, thanks for taking the time to join us this morning.
Yeah, of course. I guess I'll see if I can share my screen here. And so for us, what we've done is similar to what Lenny was just alluding to. We've set it up to where you control everything through the wizard. And so the main benefit for what our goal was ultimately to do was to make it easier for the user. So I wanted to eliminate the need to find and replace in the materials interface, to make it easier for drafters and engineers to know what information to put in, standardize the material formatting, eliminate project level materials as much as possible. So we go to our materials, you'll notice there's nothing here in the project materials folder. And so the typical way most people will use this is you'll come in here, you'll come to your PL1, and you can find and replace and say, okay, PL1 is now 4248. Or maybe you don't do that at all and you let your shop just figure out what is PL2. So we wanted to give our shop as much information as possible, accurate to what it is. So instead of saying PL2, we want to say what that is. Additionally, we wanted to be able to change thicknesses and have it be accurate and global on the fly. So what we set about doing was building it to where everything you need to fill out is in the wizard. And so everything from your, what is this spec group? And then is it a melamine interior and a melamine exterior? finished interior, finished exterior, veneer, and so on. And so you can answer, a handful of questions, and I can put in, everything that I need, and I don't have to know what is that doing in the background. I'm just literally answering the questions of what is this spec group. So my exterior color could be 49, 42-58. I can set what is my laminate standard or vertical grade or post form. You'll see here my liner color changed to BOK because I changed my melamine to black. So we started building everything in here. So we have logic built in to inform our people how to set up a spec group. So, and what that does is on the back end, it's actually changing my materials. And I don't ever have to come over to the materials interface. So if I expand these, you'll see these are red. This is what a formula material will look like. And it's actually got, it's evaluating. So you can see here, it's evaluating now and saying 4942-58 be okay. Those are the values I just put in. And you can actually see here in parentheses, this is the actual net thickness. So we've chosen that we want to not just say what is the core thickness, but then we want to say what the composite thickness is. And what formula materials allows us to do is to decide what information do we want to be in there. And then all we have to do is put a variable in the formula to have it calculate. And it's completely up to us what we want, what information we want in there. If it's available in the workbook or in the spreadsheet, so to speak, we can put it in our names. Additionally, there's things like a material code. So if you have, you're using Cutright or an IntelliStore or what does BSC call theirs? But they work off of code. So something else Lenny alluded to is if you're using ERP, it needs information. Well, all of this calculates in the factory database, which is where our library data is. But when we process a work order, those become static values in your work order database, in your outputs. So we can pack a lot of information in for other softwares and systems, like an IntelliStore, like a BSC Wooden Store, like an ERP. So other attributes like a material code now can be formulated. Material comments can be formulated. So we can actually create extra information that's formulated into extra fields. So for us, go ahead.
Jacob, a quick question. I was going to say before you leave that, it might be good to specify or just make a distinction. There are two types of Microvellum materials. So that red, like you indicated, means it's formula.
Yeah.
And so when you like right click, for example, like pretend you're going to add a new material, notice how it says add material and then it says add formula material. So it's very important to understand that distinction. You cannot convert one to the other. So right. You kind of have to start afresh and and that's just an important distinction.
Yeah, maybe that's what it'll be a little bit clear if I go to our library spec groups. Additionally, what this does is we're controlling all the pointers and everything in the background. So everything, all our materials stay template level, library level. So you see here, all of my spec group components, these are our template level components. And when I make a new spec group, all I'm doing, well, I'm in the template. All I'm doing here is making a new wizard. My template spec group, I can have all my spec groups referencing the same cut parts and everything. The only thing I have to replicate is my project wizard because all those formulas are looking back to my wizard.
Which is another, I mean, there's not a right or wrong, it's just different. You put your logic, your wizard in the project wizard. There is also, if you wanted to, you could put the wizard in the M or the E or the H workbook, which is what he's showing us right there. That is just another option. If you didn't want to overload your project wizard with too many tabs. Plus, under the hood, that might make a little more sense to some people to, put those variables in the corresponding subcomponent, spec group component.
Yeah, we actually started going down this path before those component wizards were available. So to kind of speak on the different types. So this is what a formula material looks like. And if you edit it, you'll see you have a different type of interface for a formula material. And so in the material name, I can actually put a formula in here that evaluates. And what's so different about this than even formulas in the past is this formula actually goes back to the database. And I can put formulas in each of these fields now. So we have extended data that we can actually embed information. So if we want stuff to come through for reporting, I don't ever have to touch my M workbook or go to my project materials and edit anything, find and replace. Our goal was that you go to one place and that's the project wizard, and everything that you need to set up for your spec group is there. Beyond that, everything else here ultimately is formulated, even down to the sheet components. So if I only want 4x8s available, then I just have my quantity of my other sheet sizes formulated so that I can turn on and off sheet sizes. And that, again, is something we embed in our wizard so that we know, hey, this spec group is only 4x8s. I don't have to go and add or remove sheet sizes from a material anymore. I just formulate them and say that's not available.
One cool thing about that is, in theory, you could make a product. You could put a formula that says, like a tall cabinet, if the height of this back exceeds the physical size of the sheet, then split it. I don't know if you've done that yet, but I've seen people go about doing that.
Well, and for us, what it does is, if we do optimize through CutRite or Artist, we have both. We can control what board sizes come through there and only make available what we actually have available. So, if you want to feed in information like from an ERP or from a purchasing software and say, I actually only have 10 sheets of 4x8 and 5 sheets of 5x12, you can build yourself prompts that you can actually put that information in. This goes into edge banding. We have formula edge band as well. So we put in our edge banding. Is it 3 millimeters? Is it 1 millimeter? Is it, what is the actual code that we want to populate here? All materials and hardware and edge banding, technically, which are in different workbooks, are actually formula-driven materials available. So I don't know if any of this is clicking or making sense with anybody, or if this is Greek. If anybody has any questions, I can kind of veer towards what people are more interested and curious about.
Yeah, we encourage you guys, if you have questions about this or any of the other presentations as we go throughout the next 45 minutes or so, feel free to ask them in the chat and we can get them answered for you.
On Thursday, we're going to go into this again, probably. We're going to be cracking the hood on our new library. And we do have some data in there from a shipping Microvellum data perspective that's a little bit simpler. I mean, I've done it both ways. Super simple approach to a super complicated approach or involved. I think Jacob has a good balance of effectiveness. It's not overly complicated, but it's very, it looks very cool. I'm very impressive what you guys have been able to develop.
Yeah, something that we've also tried to start exploiting is like hardware is actually a little bit different than sheet goods or cut parts, in that if you put a hardware in your product, it'll create that in your hardware workbook, whereas a sheet good has to be in there explicitly for you to reference it. So like if you go into a product, you go to your hardware parts and you just type something in, when you save and close that, it'll create a project level material basically for that. And so for hardware in particular, a lot of times we just need things to come out on reports to tell people what to pick. So instead of actually having to create formula driven hardware, we just add formula driven hardware in our products themselves. And if you don't need machining or any drawings or things attached to that, you just need it for reporting purposes, it'll do everything you need. So like for sinks or things that you're not machining that we want to add, grommets, stuff like that, a lot of times we'll just put a formulated set of hardware that the user at the prompts level can just say, oh, I'm going to have a bracket, I need 5 of them. And that'll come through on your hardware reports as an actual hardware type material. Beyond formula driven materials, a lot of what we use that wizard for is, even for drafting and how we want our construction to be. So one, if you come, we've exploited, I forget what these are, type 4, what are the checkbox type prompts?
Yeah, that's 4-0.
Yes.
Well, you put a 0 at the end of it, it'll hide it, or it'll dim it out actually.
Yeah, so these are just checkboxes that we formulated the prompt name in the spreadsheet to basically report back what people have selected. So like if I were to go, this is my poll right now, is this worth poll. If I want to go to hardware and change my poll, this is actually something else I don't think I've shown, is we made categories. But if I want to change it, I only have one worth available. So if I go to Amarok, and then I go back here, now it's telling me what that is. So if you're coming in behind drafters, say, and you want to see what they've set up, we built a summary page here basically. So it'll tell you what all is already selected through these tabs in the wizard. And this is what'll actually come out. So we add all these polls to our library so they actually come in with machining and 3D and 2D drawing tokens, all the way down to where these are how your products will come in. And grain direction, so that basically not just everything will produce right, but we want our drawings to come from Microvellum and be able to use this for drafting purposes. So, here I can draw my room, everything's in 3D, I've got all my hardware, but we've actually built it to where our 2D comes in. So this grain direction is controlled by the grain in the spec group. PO2 is coming from what I've picked in my wizard for the spec group. So I know these are on spec group PO1, these are on spec group PO2, what the grain direction is. And if I were to change something and redraw it, it would update the drawings as well. So, our goal is to not have anything kind of surprise you as an engineer. Oh, I didn't know they had spec group set that way, I missed that. I didn't know somebody went in and jerry-rigged whatever it was. It's accurate. What you see is what you get, is kind of our goal here, as well as to make it as quick and streamlined as possible. I don't know how much time you had allotted for me, Clay. I can keep filling time, or we can.
No, I think you're good. I mean, this is definitely a lot of information to take in. And if somebody's not using formula-driven materials yet, we do have some information, some help articles on our community. You can check that out. And if you want to learn more, if you're watching this and want to learn more, you can always reach out to your account manager and they can help point you in the right direction, get you some help from a service standpoint to help you get on the right path for setting something like this up. So yeah, I think that'll do it. Jacob, thanks again for taking the time out of your day to showcase that for us.
Yeah, thanks, Jacob. That was really cool.
All right. Well, we are going to shift gears again, and we're going to have a conversation with, let me make sure my screen is being shared properly, with Ben Brower from Stillwater Cabinetry. who has recently completed a project where he was faced with some unique challenges from a design standpoint in a kind of an uncommon home. So welcome, Ben. Thanks again for taking the time to join us.
Yeah, good to be here.
All right. So first off, let's get to know you for those that might not know who you are. What does Stillwater, what do you specialize in, and what's your role there?
We are pretty much 100% high-end residential.
Mm-hmm.
So all the paints and glazes and finishes and exotic wood species and hardwoods, and then cabinetry, obviously, but actually what I was going to show today is a home office, believe it or not.
How long have you been using Microvellum now? Seems like quite a while.
3.5 years.
3.5 years. Awesome. All right, so let's talk about it. I'm going to advance the slide here, and we can see some of the pictures of this home office. So what was unique about this project?
So the challenge was in the bottom right corner there, we have an inlaid metal band in a black walnut flush slab panel. And that was the door design. And as kind of an afterthought, they wanted the office paneling to match. But the challenge, as you can see in the finished photos there, is that the paneling was on a curved wall. So it is inlaying a metal band in a black walnut panel on a radius.
Mm-hmm.
So, and overlapping schedules are always a concern for every site. So we didn't have 3 months to build it in place on site. So we had to overlap the, drywallers and the painters and the floor guys. So we use solid modeling tools to extrude a shape of the wall. I don't know if you have other slides, Clay, or if you want me to share a screen. So we actually built the entire office in our shop 100% scale. So, and you can see the little notches that are in the stud walls here. I know you guys can't probably see my mouse, but the notches in the stud wall. We went and shot the room in with the laser and made a hard template just because wanted to make sure we had it right. And then in order to take out the variables of, the walls are never actually a true radius or perfectly plumb, we created I actually built our room a 1/2 inch smaller all the way around, so 1 inch overall, and just built in a 1/2 inch of shim space because all the panels were finished edges with 1/8 inch space between them because they wanted it to look like the cabinet doors, which was just a full overlay frameless box. So in order to be able to install that successfully, we just created the dead space behind it, painted all the drywall black, and then shimmed the panels to our 1/8 inch reveals on site. So our room is not, that you see here in the pictures, our room is not actually the exact same size. We are a 1 inch overall smaller, 1/2 inch behind all the panels. Then we cut all these studs, the top plates, bottom plates on the CNC. That's just particle board, just raw particle board. And then you can see in the top right, we then laced the wall with a 2 inch runner that projected out of the wall so that when we went to make our paneling, we were contacting only the radius, none of the flat of the stud wall, so that we didn't create flat sections in the paneling in between the studs. So we have a continuous radius on the wall. And then I don't think I shared this photo with you, Clay, but
You want to share your screen?
What's that?
Do you have it up on your screen?
I can, yeah. Can you share my screen?
You can share yours if I stop, so you can share yours.
All right, let me go. Oh, got it.
There we go.
Okay, so we just laid out and framed the whole thing, and that's actually my physical template laying on the floor from the site. And then, there we go. So we framed the wall up here, squared it up. And then as we went through and added all of our runners, you can see that they're sticking out of the stud wall, like I said, so we're contacting just the face of the radius. And then we laced the whole wall all the way to the top. This is our sandwich. So we had a kerf core panel with a 1/4-inch veneer panel glued to the front of it, clamped to the radius. So when the glue dried, we held our shape. And then we pre-cut, obviously, the grooves while they were laying flat on the router. So the challenge here was, from a geometry standpoint, the radius of the wall and the back of the kerf core is a different radius than the back of the face material, and it's a different radius than the face of that material, and a different radius than the polished metal band. So when everything was laying flat and you could measure it, nothing measured right. But when you bent the sandwich around the radius, everything lined up. So figuring out how to cut the metal bands so that when they were on the radius, they dropped into the groove was the fun part. Then this is just oh, that was the other thing. The designer wanted a square centered under every window on the radius. So we had to lay out all the windows onto this radius as well, so that all of them had a band. And then this is where you can see it getting shimmed off the black wall. We actually screwed it in through the grooves and then just glued the metal bands in on site and used that as our fastening method. Oops. So tall panels, and then all the metal bands installed.
So are each of these panels a product in Microvellum?
No, the biggest thing that Microvellum helped us solve was building the office walls at 100% scale. The metal band, so we did create a subassembly, a parametric subassembly for routing all of the metal bands and the doors when they're on the flat. So on the cabinetry, we did a lot of cabinetry with this detail. Those doors, we had a metal band report and everything that exported with a 30 thou gap. So we had a little bit of play, that exported to a report, and we could outsource. We ordered the metal bands out, cut the wood here in the shop. So the curves, it just didn't seem like worth it to build the product in Microvellum. I just figured out the math with one of my engineers and made this cut list.
So those faux walls you created that you showed in the earlier pictures, the framing, that's what you used to build.
Yeah, so yeah, all of this, and it's pretty slick. If you're not familiar with SMT, you really just draw a 2D view of this stud with the notches and the spacing that you want. And then in plan view, you draw the radius line that you want and tell it to extrude on that line. And it snapped all of these parts in on the spacing and nested each one of these cuts. And all the top plates, bottom plates, they get pretty slick.
All those studs are basically identical, and then you've got unique plates and ribs.
And all the ribs are identical because they're not identical to the studs. They're identical to each other, but they're inset. So they were on a different geometry. They were on a line that was snapped a 1/2 inch in from the face of all the studs and the top and bottom plate. So this was definitely the time saver of figuring out, oops, wrong way.
And I don't know if everybody saw your little bubble fillets or your little inside corners of where those ribs go.
Oh yeah.
The eternal debate of CAM engineers. Drill.
What? Meaning this way, what I knew I wanted was the radius parts to all be bottomed out flat against something that I had machined. Mm-hmm. So like Jacob's saying, we just touched each side with the bit to clean out that radius corner so our square piece can hit and bottom out tight all the way around.
The shadow looks like the torn edge of when you tear out line paper from a
3-ring binder.
Yeah.
Yeah. So Ben, looking back on this project, how long did this take you from start to finish, by the way?
Oh man, we just didn't work on it solid.
Yeah.
So, and it was kind of a pet project for me, and I wear a lot of other hats, so I wasn't
Right.
working on it all day, every day. But I would say it probably took us about 3 months off and on.
Right.
2.5
So
to 3 months.
looking back during that time, are there any lessons that you learned, things that you do differently now after having gone through something like this?
Yes, every job you have to learn something, right?
Mm-hmm.
So I'd say, and probably some of you will laugh at me, but I'll show you what I did wrong. Let me get back to my. So I ordered this 1/4-inch material without a balanced backer. So it had walnut veneer on the face and raw MDF on the back.
Mm.
And it curled before I could get it flat on the CNC, and my vacuum wouldn't hold it down. So I had to lay every one of these out, know the panel that I was routing flat, and screw a fixture down to it to hold it flat instead of letting my vacuum do the work. So I won't do that again. I'll put some maple or something on the back of that so it'll stay flat. But other than that, as far as the geometry and the templating on site and the CAD work there, I mean, honestly, all the panels went to the site, shimmed to the line, and installed on the first go. So that's a win anytime you can say that.
Right. For sure. So yeah, we appreciate you taking the time to show us this. Definitely a unique project. We didn't talk about the house much. We don't have much time to get into that, but you had mentioned that this home office was quite the home, being able to, pull in a boat inside the house.
Yeah, well, you can be sitting in your office looking at this paneling, and actually go back. Let me stop share your screen again. I didn't get that other finished photo done.
Yep. Hold on a second.
Very brave of you to share your personal residence, Ben.
I didn't want to bring it up, Jacob. Thank you.
You should be able to see it now.
Yep. Click back to the finished photos. So this right here in the left panel there, you can see all the glass wall. So that glass wall, you walk through that door, that's into the office with the radius room, and you can see all the wall paneling that's not radiused, and then that's a bar off to the right beside the office. All, if you zoom in, that's all back panels on the peninsula. All that has the same metal banding. And if you were able to turn to the right here, it's a wall of glass, and you have a 65-foot yacht you can pull into your living room and shut the door behind it.
Nice.
So boathouse attached.
Yep, definitely a unique project, a unique house, and great turnout. I think it turned out really well.
Thanks.
Yeah, so thanks again for taking the time to showcase this for us. All right, let's talk to our next guest speaker here. We got Tyler from Eurowood Cabinets. Welcome, Tyler.
Hey, Clay.
How's it going today? End of your day?
So appreciate it. Yeah, thanks for having me.
Yeah. So if you're like most shops, you're probably using the events of this past year to analyze your processes, your workflow, maybe even the software that you're using. And like Tyler, the types of machinery that you're using. And so what can you tell us, Tyler, about what you have recently done there at Eurowood? What was the problem that you were trying to solve?
Sure. So, December, nobody knows what 2020 is going to be. We, made a deal on a material handling system. I guess I should back up and say, so we are primarily like high-end residential, kind of like Ben here in Omaha. So I would say like the images that you had up there, those are pretty much the level of work that we're doing. Probably 70% that, 30% commercial. But we were looking for a way, so, same issue everyone's having, and that's getting good help, good work, consistent output and stuff like that. So over the last 3, 4, 5 years since I've been involved in the family business, we got involved in a nested base router, edge bander with return conveyor, air tech on the edge bander. But most recently, we put in a StoreTech HomeAgs material handling system. And like I said, that was deal was made in December. Then we all know how 2020 has been going so far. So 6-month lead time on some equipment like that, we're kind of looking like, oh boy, what's going on here. I don't know about you guys, but knock on wood, right now we still got a heck of a lot of good work on the books. So, but super exciting. We made the jump. The integration just got done maybe like 2-3 months ago, something like that, and would not turn back. It's been just great.
Mm-hmm. So how are we connecting to it? And first, did we talk about the problem that you were trying to solve by getting this machine?
Not really. So, I mean, same thing as like I brought up, but I'm sure everyone's experiences is just good people, especially when you're doing high-end custom. There's probably like a misconception about like this level of technology where you have to be like a high volume shop to really get the benefit from it. In a way, I would almost argue the opposite. If you're using a lot of different materials, and like Jacob was saying, we haven't really gotten into the formula-driven materials much, but we are using just a really high variance of materials, 3/4, 1/2 inch, 5/8, white, black, green, blue, whatever, you name it. So going through all that, and we were having trouble, one of the challenges was every step you take, you find something else that you need. So we put in the nested-based CNC pull-on push-off Van-Tech router with a scissor lift. And the problem is, your run batch is pretty much 1 or 2. Like say you're running a sheet of black, you can get that one through the whole process, but you have to wait for that process to complete before you can get the fork in there, unload that bung, go grab the white, bring it in, set it down, run it. So we said, how can we eliminate that? And the StoreTech is just completely taken that away, because you can queue up, white, black, green, blue. I can actually share my screen. I loaded up Wood Store.
Okay, I'll stop sharing.
All right, you guys seeing that?
Yep.
So if I load up like the CNC production list, you can see up here, and all the systems are probably similar, I would imagine, like BSEs and all the other guys. But when you send from the office, so we're using Microvellum, of course, and that's another part of this discussion. I don't have too much time, but we also, the kind of hiccup is we also are a heavy scrap management user. So we're managing our offcuts in Microvellum, and getting that all to work has been somewhat of a, what do you call it? Not a challenge, I guess a challenge. We got it working now, but it took a while to get it working right. But yeah, so up here is our completed patterns essentially. So, say you're running a job and you send from the office, here's this Burt pantry. We have, 19 millimeter white, 4x8 essentially, about, 15 patterns of it, whatever. But here's where, and I was going to jump in, but I didn't want to interrupt you, Jacob, but I'm curious how this would all work with the formula-driven materials, because like you mentioned, that handling code, I'm not sure. Let me see. I'm going to cast a different screen.
Are you connecting data directly to this, or are you importing it through reports?
It's like a direct, like an output file basically. So it's just it's a PN or a PTX is what it is.
Yeah, if
just
you're
like
using the PTX, it would still work with formula materials.
Mm-hmm. Yeah, I'm sure it would, but with the scrap management layer on top of that is the only, so because scrap, each piece of scrap has a handling code, and the handling code is what the store recognizes. So we don't have to get into those weeds, but that would be like one thing that I think would be interesting to talk about. See, I don't know if you guys have a store, but if you guys do that, how that works. But using Microvellum's optimizer is great because, it gives us a lot of flexibility. But then you're also having to, mesh the 2 different softwares. So that was the challenge. We've gotten past it. It's been working great now. So let me go real quick. So are you guys seeing my specification groups?
Yeah, we see it.
Yeah, so for anybody that doesn't know, so each material has like essentially how the store reads this. The material description in Microvellum is like the handling code, and the handling code in here is actually the board code at the store. So like this here, this code is what the store recognizes as the pattern. So if we load it in that program or that project, if you will, created a work order, sent it, then the output file would show like, you know, all these sheets of, you know, 3/4 white, 4x8, all that stuff. And then, like you guys saw first, yeah, then in Wood Store, it recognizes that. So the challenge that, you know, really a lot of this stuff is just, you know, as you run into it, you figure it out. And then once you get it working on the front end, kind of like Jacob was saying, you know, for your designers and you're picking your prompts and you make it easier on your, you know, programmers. So there's not so much manual labor. It's really just set up on the front end. So now that we've gotten past a lot of those hurdles, it's just create a work order, attach that processing station, hit go, and then next thing you know, all your patterns are here in the store. So I can rearrange this all I want. So if I wanted to run this MDF sheet, let's see. If I wanted to run that MDF, I can just drag and drop it up to the top of the list here. Pretty much, boom, it would slip that into the list. It would run it. So it's very flexible is what I'm trying to say. And it's worked. It's just been great.
So looking, I mean, obviously this is not a cheap machine. It's quite an investment. And so right now you mentioned that you're staying quite busy, but looking back, would you have made a different decision, or do you feel pretty confident about the investment in such a machine for your company?
We're very confident in it. I mean, it's one of those things. Our goal is never to replace the people that we have, because we have a great team. But our goal is, you know, when you lose that person to retirement or whatever it may be, you don't necessarily need a backfill. And if you do, it makes us more, what do you call it? Just to like a younger, like newer technology oriented crowd. Because woodworking now, I mean, you know, it's 50% woodworking and the rest is, you know, it's database management, like I was talking about. It's really understanding that, you know, like ERP systems, all that kind of stuff. And that's what I love about it. So yeah, I wouldn't look back one bit. The only concern was, you know, you're sitting on March 18th, like, oh crap, you know, we just spent what we spent on this thing and, you know, we can't turn it down now. So, but like I said, things seem fine across the industry. So no complaints, but yeah, wouldn't look back.
That's awesome to hear. Yeah, and at another time, maybe we can get into more about how you're using the scrap management. I think we did feature you in a live event a while ago. It'd be nice to do a part 2 and see how you're integrating and do a longer session on what you've got set up here.
For sure. All I'd say, just to make it quick, would be these, what we're having in the output file from Microvellum. It'd be different if we were using Cut-Right, but we use Microvellum for our optimization. We are actually, are you seeing my screen still?
We do.
So yeah, whenever there's a scrap pattern in the optimization, I could pull it up, but most of you guys probably know what it looks like. But in your composite or your optimization, when there's a scrap pattern that you're going to use, the PTX populates with that scrap code. So X is what software recognizes offcut. And MV scrap is our signal to our operator. Okay, this is a piece of scrap that I'm pulling from our rack. And I don't know, Clay, if you want to put your screen back up there. Yeah, so then this would be like our offcut rack, or one of our 3 offcut racks. If you can see, when we're generating scrap off of a pattern, the operator writes on the edge of the board the code, and then the label actually populates with the data of where to put that piece in which location. So then down the road, you know, next 3 days later, or, you know, a week later, whenever it calls for that board, he knows exactly where to go and grab that piece and load it from the front. And when it's a white, you know, pattern from like what you guys saw on my screen, then the store knows, okay, that's in my inventory. I'm just going to grab that, load it from the upstream machine.
All right. Well, again, thank you for taking the time out of your afternoon. I know you're quite busy. And by the way, I failed to mention and congratulate both you and Jacob for making the Woodworking Network 40 under 40. So congrats on that.
Thank you. Appreciate it.
All right, so let's get into our next and final segment of the day. We're going to invite up Matt Davies. One of our slogans is building beyond simple cabinetry. And our next part, we're going to focus on how Matt, an account manager in Australia, has helped a client engineer something that you may feel is out of the ordinary for us, for use in Microvellum. Perhaps a few of you will have your eyes opened in terms of what the possibilities are of what you can engineer with Microvellum. So thanks, Matt, for getting up early and taking a few minutes out of your day to join us.
Yeah, no problem, Clay. And thanks for having me on. I'll share my camera. It's pretty early in the morning here. Yeah, so yeah, I've got a fairly unique a few customers down here in Australia actually build RVs. So we call them a caravan. You guys might call them an RV or a trailer. So yeah, we're starting to lead the industry down here for software in that sector. So what I'm about to show you is a product that I personally built for one of my customers as kind of a swap for labor, and it's a pretty cool product, and it's saving him hours and hours every time he builds a trailer. So if you want me to share my screen there, Clay, I'll get in and show you what we've built on Microvellum.
Yep, sounds good. You should be able to do it now.
Okay. All right, so I'm just going to draw one from scratch. So I'm going to start a RV, got one saved here. So I built a product called a van builder. And what the van builder does is you can put in the width of the van, which is pretty much a standard. He has 4 ranges of these vans that he builds. So he's got a Matrix, a Trax, a Vortex, and a Vortex Evo. Whichever range it is, it'll completely change the shape. So instead of having 4 products to do one thing, it's one product. He can specify his length, and for some reason, vans in Australia and seem to be worldwide are done in feet, which will probably be comfortable for you guys, but we always work in metric here. But for some reason, the lengths, they talk in feet. It must be because old people typically have RVs, so they like feet. So if I want a 21.5 foot van, I have that there. It calculates the length of the van depending on the range. It'll automatically select how many wheels it needs. So it's got a dual wheel set on it. The wheel set location is also automated as a formula. So depending on the range, it'll move the wheel set forward and backwards. You can specify the door location, how many panels down each side of the van, whether it be on the driver's side or the passenger side. They call it roadside and near side on these because there's no driver. We can have a cladding quantity. I can have a van length override. So all of this is just prompts that I've put into it to make it easy. I can hide things like the chassis or the wall panels or the wall framework just to make it draw quicker. And then we can position all of the windows. So you can quantify the windows down the side of the van. You can select from the library what windows you're wanting to use. So you come into the Windows category. So it's a prompt type 9, if you're familiar with that. So you can select from your hardware list directly in there. Those windows have all the cutouts associated to them. We can have wall mounted hardware in here. You can position, even the toilet can be positioned on the van because it has a hatch that you need to get to. We can keep adding hatches to the side of the van. If I add a hatch, you can position the hatch. I've got it color coded, so the cyan color here will match the one that you're working on. Roadside machining, we've got a bunch of machining that does all of the connectors for connecting the wall. The walls are actually made out of 18mm lightweight plywood. Then we've got additional hardware, so you can just keep adding hardware. So he can sit in front of the customer and say, okay, well, what toolbox would you like? What heater would you like? What fridge would you like? What washing machine, TV, microwave, batteries, charger, inverter, water tanks, All of that. And then you've got your roof hardware. So what air conditioner is going to be sitting up on the roof? Do you want solar panels? How many solar panels are you going to have? And then we have some drilling and also exterior lighting. So how many lights down the side of the van on the outside, the position of the light. So once you've filled it in, you hit OK, and it's going to build that van. So it takes a while because there's a lot of parts in this product to draw. And you'll see the level of detail once it's drawn. So, okay, there's the van. So this van is not only quantifying and I'll just spin this around rotate this around so you can see it. This van is quantifying everything. It's also quantifying all of the steel work in the chassis. It's positioning and quantifying the wheel set, the windows, everything is quantified in this as well for estimating. So I can put this straight through into estimating, and it will price that van accordingly. So it's pretty slick, and it's so much quicker than what he was doing before. So if I change the range on that to a different range, and I'll show the wall framework and the paneling so you can see how we construct these. It's quite a different method of construction in these vans, where we're using like an old aircraft wing, how they used to build aircraft out of plywood. We're doing the same for the front and the rear of the vans. So you'll see in this particular, oh, that's the wrong model I've selected there.
How much of this is CAD blocks versus extrusions or parametric parts?
All of these are individual parts. There is no extrusions in here. It's not done on solid model analyzer. This is every part in this is a product. It's a part of the product, so, or a sub-assembly. So you see here, I've changed the range of that van. So now it's a different shape. The rear is a different shape. The front's a different shape. The windows and everything are in the same location as specified, but the van has changed shape. But here we're using an interlocking system, like I saw that in the previous demonstration, or the one before that Ben was doing. Same sort of thing, although instead of using the router to create those holes, we don't want to take too much meat out. So we're actually drilling those holes. So if I drop that part into 2D, we're actually drilling those out. So we have these holes drilling in the corner, so it just makes it quicker. So the drilling sequence is quicker than the router. The router can just come in and out rather than pulling up and down. It was just an easier process for us, with less blowout as well, and easier on the cutters, because this lightweight ply is pretty hard on cutters. So that's worked really well. So these are just parts that are programmed with polylines, and each one is obviously, it's all formula driven, but go back to the product. Yeah, so that's all interlocking and glued together, the whole framework of the back of the van. The side of the vans, we've got a keyway connector with a hardware part. So if I drop those parts down into 2D, you'll see here that we've got a rebated interlocking, like a butterfly connector is what we call it. And that's a hardware part. So that hardware part can be moved up or down, depending on wherever the wall goes, the hardware goes with it and creates that route, which is a rebated route. So they just lay the plywood down. So if you look at this this plywood, so this is this van looks kind of weird with all these routes going off the page, but that's a virtual route that's creating that line. So wherever that virtual route ends is where it is, but once it nests, it'll only go to the edge of the sheet. So you would never see that on the nest pattern, but you can at least then get an idea of where that panel sits within the whole van. So the whole shape of the van is created by virtual routes. The windows, so all of these can be controlled in the prompts to move these connectors up or down, depending on where they are, but that'll route that out. Again, being that it's a route coming from the hardware, once it goes in a nest pattern, this will be created as a border route, and this will be a second route, and that works really nicely. I've even got the, that's the route for the position for the electrical inlet into the van. We have some holes that are driven for, you know, for tunnel boots and things like that. We also do some phase 6 machining on this that indicates positions of things that we don't want to drill, so he doesn't run any phase 6, but it's just indicating on the panel so that if he's dropping parts into 2D, he knows where things are, and that's the light, but that will get attached, but it gets drilled through from the face later, but that's a light coming through for the side of the van. So yeah, it's a pretty interesting and unique product, which yeah, if I quantify that, I'll just send it through and show you how the estimating's working on this. I'll just process this out. It processes pretty quick because it is just one product. So if I create a work order, it's amazing, this product. When COVID hit, we just started building this, and then they cancelled all of the caravan industry in Australia, or the RV industry in Australia cancelled all of their shows. And then they started to, the first show that they did was a virtual show, pretty much like what we're doing now. And Lenny, my customer here at On the Move Caravans, they're called, was the only person that could do live walkthroughs and demonstrations and actually show people what their van and build vans in front of them using Microvellum, which was so cool. I helped him with that process, and it was just so cool to have people coming along instead of just looking at a PDF glossy brochure on the screen. We were building vans for them in front of them. Say, okay, what length would you like? Okay, would you like the door at the front of the van or the back of the van? You know, where would you like your furniture to be? So yeah, it's pretty cool. So I'm just going to come into the cost report here, or even the quote report. It'll price that van straight up. So here's my quote report there. So that's a $94,000 van. That one there, that's a 21-foot van. That's Australian dollars, with everything in it that we have selected. From that, I can actually get my cost report and see all the costs and anything that I've missed. So so in here, I can see all of my sheet stock, my solid stock, my buyout materials. If I zoom in a bit so we can see it. And then we have all of our hardware. So everything's in there. It's all pricing pretty well. So we've got, yeah, there's a few things like this butterfly connector. Yeah, that's that piece of hardware that connects. I've got $0 in there for that. We could put a price to them, but they are just cut out of the plywood. But you could put a price in there. So yeah, it's pretty cool. Not sure if anybody knows yet, but about this feature in Microvellum, but we've got the ability to modify our work orders. And watch this space, because in here we'll soon have the ability in the next, I'd say month, Clay, with our release to as the beta, we'll be able to actually edit hardware in here. At the moment, we can edit sheet stock. Yep. So, which is really cool. You can change the name. So if you wanted to change the name of that material, you can change the name of that material. So you select the name and change it to whatever material you want. You can change the sheet sizes as well. The only thing you can't do is change thickness. Obviously, that will affect everything moving back. But for now, in the current builds, we can edit anything to do with materials, but if sheet material. But soon we'll have the ability to then add or edit hardware, as well as within that hardware, you'll be able to edit not only the price of the hardware, but also the labor value for that hardware. So if you're pulling reports with your estimating, you'll be able to jump into that screen, modify that price for that hardware and the labor content, and then save that back to your template. So that it'll give you the ability to fine tune your estimating on the fly, and then just re-pull the report and it'll be done. So rather than having to jump right out and go back into your spec group, make the changes in your template spec group, pull that into the project, and then reprocess and rerun the report, we'll be able to do it all within this window, which is going to make your life, all of our customers' lives, really easy and super fast for estimating.
So that beta build's coming out, should be out next week.
Next week. Okay, cool.
Yep.
Which will be really nice. I'm really looking forward to that, because there's a lot of times where even myself, when I'm doing a demonstration of our software, will find that I've got zero labor content in a piece of hardware, or use a piece of hardware that I've never used before and I haven't set it up, where having this interface and be able to do that on the fly is going to make that super quick and super easy. And then it's basically tweaking your template as you go. So it'll be really nice. Yeah, so any questions, or anyone want to see anything different?
Are there cabinets in that, Matt?
We've got a whole bunch of cabinets. So the van builder does the van and it does the bed. And then we have all of the products as separate products. It's too heavy to try to build the cabinets in as sub-assemblies into the product, because it's too varied. So we decided to keep the van structure as one. And then we have all of the, so then what you do is go and drop in all of your cabinets. So you'll grab fridge cabinets and angle cabinets, and these are all built to suit how the RV works. And you just basically go and put your cabinets in. It takes about half an hour for them to go and lay out all the cabinetry from scratch if it was a custom van. Then what he's been doing is, once it's all laid in there, he will save that van as a 21'6" matrix with a forward door, and lay out template A, and he saves it back into his library. So he doesn't have to build the vans from scratch each time. He's basically using this product as a way of building his library up of his vans. And then he saves that as a product group. So he'll bring the whole van in with all of the products, and I'm not sure how I'm running this type of thing. So if you've got, you can just bring that van out, and that's how we've been doing it. So he'll have all of those vans that he's built as a product group. Yeah. So yeah, it makes it fast. But this is more about for him to build and save back to the library.
So when it comes to manufacturing this, obviously we're going to be, those internal studs are going to go to the router, but what other parts are we providing manufacturing data for?
All of the wall paneling, I'll process it, Clay, you'll see it. You'll see the nest patterns for all the walls. Some of those, sorry, I've made all those sheets too big because I didn't recalculate and make two more wall panels, but it's doing all of the wall panels. It's cutting all of the aluminium composite board, or aluminum composite board, whatever you guys call it, on the outside of the van as well. So yeah, I've just got no path here because I'm using my customer's data without a Y drive. So it's cutting all of the composite board on the outside of the van. It's cutting all of the internal 3mm plywood on the inside of the van. It's cutting the 18mm plywood for the walls. It's cutting all of the plywood at the front and the rear to create that I'll get rid of all of that. Sorry about that. I didn't expect to optimize this. Yeah, so it's cutting everything, Clay, except the only thing it's not cutting is the roof panel itself, because it's I haven't got a way that I can have one part which is made out of fiberglass that rolls from the front all the way around to the back of the van. So, and it's one piece with a whole bunch of folds. So we can only do, I can draw it, I've got a drawing, but we can only obviously bend a part that goes from point to point with a bend of the radius. So we can't have multiple bends within a part, but that's the only thing we're not cutting. But they actually don't cut that on their CNC anyway. So if I go to my 18mm wall panels, so yeah, it's cutting all of this. But yeah, if I had the wall sheets, because they're 24x12 sheets or 8x4, the van that I drew, I didn't put enough wall panels down there for them to fit onto that sheet. So that's why I got all those errors and it didn't optimize that. But yes, it's cutting all of this out.
Nice.
And yeah, all of the wall panels. So it cuts out all the holes for the windows, the doors, everything. So What they were doing before was they were cutting it out on the CNC, but they were doing part by part processing. So every single part, he was dropping into 2D, drawing every single route on that, and getting a lot of mistakes where window positions or hatches were in the wrong location. Now it's all done from the builder, and he gets all of that in the right spot every time.
Mm-hmm. Yeah, I imagine a lot of companies that are doing this type of work may use SolidWorks or Inventor or some other kind of CAM package to build these parts out one by one.
Yeah. Typically that's what they using AutoCAD through to a post-processing software or something like that. This is giving them the ability. Now it's all in the database as well, so we're getting all those quantities, which is where he's picking up a lot of his time with his estimating as well.
Yeah, and that's the bonus in this whole scenario, right? There's it's one thing to be able to provide the engineering data, but another to provide the customer with project costing information. So detailed, right. Super accurate. Yeah. So now
it's pretty cool. It's saving him a lot of time. I talk to him most days, and it's still like a new toy for him. He just loves it. He goes, right, I've got to get into my van builder now and build another van. He's really pumped about his business, which is really nice to see.
Yep. Well, that's great. Really appreciate you getting up early and helping us with this tour of what you've been working on. That's great.
Yeah, no problem at all. Thanks for watching.
We appreciate you taking the time to join us. Some of you have been here all day, and that's quite impressive to see. We will resume our schedule tomorrow morning at 7 a.m. and we invite you to come back. Our schedule will be the same topics will be repeating, but the content, as you might have seen today as opposed to yesterday, will be changing as we go through. And so you're learning something new every day that you're coming. So hopefully you learned something new to help you streamline the way you work, and we will catch you again tomorrow morning.